Hey, I'm Trevor from the Human Powered Vehicle Innovation Team, and I'm going to give you a quick overview of our project. In terms of mounting, we have a main electronics module and a bunch of sensors all over the bike that are very easy to take off, move, and this allows us to switch bikes very quickly, which we have to do a lot. Now, keep in mind that this isn't the final mounting setup, and that it's all optimized for the actual bike, which is in a fairing right now, so we opted for a more open view. Our main sensors are heart rate, speed, cadence, and gyroscopic data. So if you look over here, you'll see our cadence sensor and display. So if I do this, it'll spike. Now this LED is going to be a little bit brighter. We're still getting parts in, but essentially we use this to optimize riders' shifting times, and it can also display heart rate and speed data. The major benefits of the system over a traditional fitness tracker are you get more information, you're able to see that information with an integrated display, and you can do more with it later. So now we're going to look at the app and how you can actually analyze everything. This is the final app, the real meat of the project, where all the data goes and we actually do something with it. So you can see here that we have a lot of different options, and we can plot anything on the X or Y axis. So if you want to do something basic like time versus speed, you choose your plot type, choose your rider, right now our rider is Fritz, and this is our ride date, and it just initializes the plot just like that. We can see power 2, fairly closely correlated because this is just the bike's output power. Or if we wanted to do something a little bit more complicated, we could do speed versus output power, and that relationship is just determined by the grade, by how much the bike is leaning. Now, if we do time versus heart rate, you can see that it's still a bit shaky just because it's actually vibrating a lot. So once we get our mounting method together, then I expect that to go down a lot. Now we can also handle multiple rides. So if we were to look at distance versus speed, we can see that the rides are a bit different length, and we can also do distance versus, say, lean, and we can see the correlation in lean because this is over the same course, and so the rider is leaning at around the same time. We've added cadence to our program to make up for the issues with heart rate sensing, so now our finished product has integrated sensors, displays that can show either cadence or speed, and an app that stores everything including power and orientation. And one important thing to note is that everything that we collect is instantaneous rather than being derived after the fact. There's a reason that no car speedometers use GPS data, it's just not accurate enough. So the goal for this entire project was to make something that goes above and beyond a fitness tracker in terms of helping the riders to see their progress and to go faster. And the rider diagnostic system was a success in both regards. Thanks for listening.